Welcome to all. Our today's topic is biaxial stress analysis. When a mechanical component or 2D mechanical component is subjected to two normal stresses on two mutually perpendicular planes, that is called biaxial stress. So this is a 2D mechanical component and it is subjected to two normal stresses along two mutually perpendicular directions. So sigma xx is normal stress along x direction. Say this is x direction and this is y direction. And sigma yy is normal stress along y direction. So this stress situation is called biaxial stress. Now, what is our objective? Our objective is to determine the stress value on a plane. Say this is one arbitrary plane whose normal, say this is the normal to the plane, n is the normal to the arbitrary plane, makes an angle phi with x, makes an angle phi with x axis. So we have to calculate stress on that arbitrary plane. Let me give a name, that is, say this point is A, this is B, this is C. To calculate that, let us draw the free body diagram first. That is free body diagram of that portion ABC. So first of all, let me draw that. So ABC. This is A, this is B, this is C. And along this stress is sigma xx. Along this direction stress is sigma yy. This is normal to the plane. So this is normal to the plane and that makes an angle phi. So this angle, obviously this will be also phi. Now what are the stresses on that? So stresses on that, along that, this is the shear stress. So this is the shear stress and this is the normal stress, sigma n. Let me denote it, erase it. N, I am erasing n now. So these are the stresses. So sigma n is normal stress on that plane and tau is shear stress on that plane. So now let me define another things, that is area of face AB. Area of face AB is DAX. Say area of face BC is DAY and area of AC, that is this plane, is DAN. Now let us make, at equilibrium we can make force balance, that is summation of all force along n is 0. This was the n direction, this was the n direction. So summation of all forces along n must be 0 at equilibrium. This is the equation of statics. So what we will get, that is we will get sigma n, area is DAN, sigma n, area is DAN, minus sigma xx dx, DAX, that is the force, because this area of AB is DAX, into cos phi minus sigma yy, area is DAY sin phi is 0. So this is the force balance equation. Now here we can develop another relationship between DAX, DAY and DAN. What is DAX? DAX will be DAN cos of phi and DAY will be DAN sin of phi. So this is the relationship between dAx, dAy and dAn. Now replace dAx and day by dan. So what we will get? Sigma n dan is equal to sigma xx dan cos phi cos square phi plus sigma yy day sorry dan sin phi sin square phi. So sigma n is what? Sigma xx cos square phi plus sigma yy sin square phi. We can modify this equation, that is sigma n is half of sigma xx, 2 cos square phi is 1 plus cos 2 phi plus half of sigma half of sigma yy, 2 sin square phi is 1 minus cos 2 phi. So sigma n we can write sigma xx plus sigma yy by 2 plus sigma xx minus sigma yy by 2 cos 2 phi. So this is the expression of normal stress. Now we can simplify it by considering that sigma xx plus sigma yy by 2 as sigma average. So sigma average plus sigma xx minus sigma yy by 2 cos 2 phi. What is value of sigma average? Sigma average is sigma xx plus sigma yy by 2. Now let me write down it in next page, that is sigma n is sigma average plus sigma xx minus sigma yy by 2 into cos 2 phi, where sigma average is sigma xx plus sigma yy by 2. Or we can write sigma n minus sigma average is sigma xx plus sigma yy by 2 into cos 2 phi. And let me give this equation number 1. So this is equation number 1. So we have determined the normal stress on the arbitrary plane whose normal makes an angle phi with x. Now what will be the shear stress? So further we have to go for the free body diagram. This is the free body diagram, and as we have already done this, so right now I can erase this part here. So let me erase this first, because we need this free body diagram to calculate tau. Now let me calculate tau. To calculate tau, what we will apply? That is equation of statics, that is forces along AC, that is AC is 0. By doing that, what we will get? Tau dan minus sigma xx dax sin phi plus sigma yy day cos phi is 0. So tau DAN will be sigma XX DAN sin phi cos phi cos phi minus sigma YY DAN sin phi cos phi cos phi. So tau becomes what? Half sigma XX minus sigma YY into 2 sin phi cos phi, which is nothing but sin 2 phi. So this is the expression of tau. We have determined tau also. And let me write down it in the other page where we have written the expression of sigma n. So we got what? Tau becomes sigma XX minus sigma YY sigma XX minus sigma YY by 2 sin 2 phi. And let me give a equation number to this equation, which is equation 2. Now please make a correction because I have done one mistake. So from this equation to equation 1, sigma n minus sigma average was, this will be minus here. So this sign will be minus. This was minus, so this will be minus. So we got two equations, that is one for normal stress, another one for shear stress. So right now if we do that, we make square in right hand side and left hand side and right hand side of both equation, that is square of equation 1 plus square of equation 2, then what we will get? That is sigma n minus sigma average whole square plus tau square is what? Sigma XX minus sigma YY by 2 square, 2 square. This is cos square 2 phi. This is also sigma XX minus sigma YY by 2 into. So we will get cos square 2 phi plus sin square 2 phi. Cos square 2 phi plus sin square 2 phi is nothing but 1. So sigma n minus sigma average whole square plus tau square becomes what? Sigma XX minus sigma YY by 2 square. Now this equation, say this is equation 3. This is equation 3. This is analogous to what? X minus a whole square plus y square is equal to r square. Because here variables are what? Variables are sigma n and tau, and in this equation variables are x and y. Other terms, that is sigma average, which is a constant, and sigma xx minus sigma yy by 2 is also constant, so r is also constant. So this equation, say this equation is what? This equation is a equation of circle. So this equation of circle is in which plane? That is xy plane. But here that stress equation, that is equation number 3, is on which plane? That will be on sigma n tau plane. So sigma n tau plane. Now what we will get? We have got, that is sigma n minus sigma average whole square plus tau square is sigma xx minus sigma yy by 2 whole square. So this is a circle, and this circle is called what? Mohr's circle. This circle is called Mohr's circle. Now how to draw the circle? This circle is drawn in, we have already seen, sigma in tau plane. So first of all, we have to draw these two axes. This is sigma n axis, this is tau axis. Sigma n axis and tau axis in sigma n tau plane. Then we locate point A whose coordinate is sigma x comma 0, and point B whose coordinate is point B, this is point B whose coordinate is sigma yy comma 0. Sorry, I am extremely sorry, this will be sigma xx comma 0, this will be sigma xx comma 0. Now what to do? Midpoint of the AB says C. Say this is C. Now taking this center, C as center, if we draw a circle with CA as radius, that circle will be like this. And this is nothing but the Mohr circle. Now what is the, say this is point O. What is the center of the Mohr circle? Center of Mohr circle, coordinate of center of Mohr circle is OC coordinate. So OC is what? OB plus BC. What is OB? OB is YY, sigma YY. What is B to C? B to C is sigma XX minus sigma YY by 2. So center becomes sigma XX plus sigma YY by 2. So this becomes sigma XX plus sigma YY by 2, that is nothing but sigma average. So center is C, coordinate of center is sigma average comma 0. This is the center. Now what is radius of the circle? Radius R is sigma XX minus sigma YY by 2. In that equation, that is equation 3, this is the equation 3, equation of Mohr circle. So here R is also, sorry, so in this equation, this is the R square, this term is the R square. So R is nothing but sigma XX minus sigma YY by 2, that is CA or BC. Okay. Now the question is that we have drawn the Mohr circle. But what is the utility of Mohr circle? What we will do with this circle? So what is the utility? The question is utility of the Mohr circle. What is the use of this? Or better, we'll use term. What is the use of Mohr circle? What is the use of Mohr circle? So let me draw it in the next page and explain it why we will draw the Mohr circle. So this was sigma n, this is tau, this is point A, sigma xx comma 0, this is point B, sigma yy comma 0, this is point C, and this is the Mohr circle. And this is point C, and we have already calculated that this value is sigma xx plus sigma yy by 2 or sigma average. Now let us draw an point D on Mohr circle. This is D such that this angle is 2 phi. This angle is 2 phi. That is angle DCA is 2 phi. 2 phi. Then if that is 2 phi, what is the coordinate of point D? What is the coordinate of point D? So say this point is E and the origin is O. So sigma n coordinate on of point D is what? OE. OE, we can write OC plus CE. What is OC? OC is nothing but sigma average or sigma XX plus sigma YY by 2. What is CE? CE is CD cos 2 phi, that is sigma average plus CD is the radius of the Mohr circle, that is sigma XX minus sigma YY by 2 into cos 2 phi. OE, this is value of OE, that is x coordinate of point D gives the value, same value of normal stress which we have found in our analytical method. What was the expression of normal stress? That was the same with that. And so coordinate of point D is giving the same expression of normal stress. Normal stress was same like this, was sigma average plus sigma XX minus sigma YY by 2 cos 2 phi. That is, if this is sigma XX, sigma XX, this is sigma YY, and this is also sigma YY, and that plane whose normal makes an angle phi with x was the normal stress was this expression, normal stress, and coordinate of point D, sigma n coordinate of point D gives the same expression. That means what? In practical, a plane whose normal makes phi angle with x, and here the D, that is means orientation of D such that DCA is 2 phi, that is angle becomes doubled in Mohr circle. That is, by plotting D we can calculate the expression of normal stress. Similarly, we can if we take the tau coordinate of D, what is tau coordinate of D? Tau coordinate of D is ED. What is value of ED? That is CD sine 2 phi, that is sigma XX minus sigma YY by 2 sine 2 phi, which is exactly same with the expression of tau, because tau was what? Tau was sigma XX minus sigma YY by 2 sine 2 phi. So if we can draw the Mohr circle, then we do not have to go for this tedious calculation to calculate the stress expression. Directly from geometry we will get the values of normal stress and shear stress. Now let me explain these things through an example. Let us consider that this is one biaxial stress, say 100 MPa, and here it is say 20 MPa. 20 and 100. And one have asked that what is the normal and shear stress value at an angle whose normal makes 30 degree to the x, that is, this is the normal direction and this angle is 30 degree. So without calculating, without analyzing by the free body diagram, by drawing the Mohr circle, we can calculate the stress values. How to do that? We will plot the Mohr circle. We'll plot the Mohr circle like this. Sigma n, this is tau. So first of all, this is 100. So we plot here 100 sigma x. Then we plot 20. So this is the center. So this is the center. Now here actually the angle is 30 degree. In Mohr circle we will make it double, that is we will make it 60 degree. And this is point D, This is point A, this is point B, this is point C, and this is E. So normal stress is, if this is O, that is OE, that is OC. What is OC? OC is 60 sigma xx plus sigma yy by 2, the 120 by 2, this is 60, and radius of the Mohr circle CD is 100 minus 20 by 2, that is 40. So OE is the normal stress, that is OC plus CE. What is OC? OC is 60 plus CE is 40 cos 60 degree. And what is, so this is the normal stress. OE is normal stress. So OE is the normal stress on 30-degree plane. And what is shear stress on 30-degree plane? That is tau 30-degree will be what? ED. That will be CD sine 60 degree. So simply by drawing the Mohr circle, we can calculate the normal stress and shear stress on any arbitrary plane without doing the tedious calculation like previously we have done from the Mohr circle. So this is the utility or use of Mohr circle. Now let me show you another point, that is point A coordinate. Point A coordinate is sigma xx comma 0. That is point A representing the stress state at a point where phi equal to 0. Now B representing sigma yy comma 0, that is stress state of this plane, and where phi is 90 degree, because x and y are, angle between x and y is 90 degree. But in Mohr circle you can see the angle becomes double, that is here the angle between A and B is 180 degree. So when we plot in Mohr circles, the angles becomes double from the actual. We have already determined the expression of normal stress and shear stress on a plane whose normal makes an angle phi with x-axis, and these are the expressions. Now let us calculate the complementary stresses. Complementary stresses means the stress value on a plane which is mutually perpendicular to another plane. So the plane, say this was the arbitrary plane N. Now we are going to determine state of stress on such a plane whose normal makes another 90 degree. Say this is the 90 degree, so this is N prime. So on this plane, what will be the stress value on mutually perpendicular plane to that arbitrary plane? So what will be the value of phi if this was phi and this is 90 degree? So we have to replace phi by phi plus 90 degree. So what is the complementary normal stress? Sigma n prime is sigma average plus sigma xx plus sigma yy by 2, sorry, this will be minus cos 2 phi, that is 180 degree plus 2 phi. So tau, sorry, sigma n prime is average. So this is minus cos 2 phi. So minus sigma xx minus sigma yy by 2 cos 2 phi. Now the relationship between sigma n and sigma n prime will be what? That is sigma n plus sigma n prime. Sigma n plus sigma n prime is what? 2 sigma average. That is sigma xx plus sigma yy. So we got the relationship of complementary between complementary normal stresses, that is sigma n plus sigma n prime is sigma xx plus sigma yy. Now what will be for shear stress? So for shear stress, what will be tau prime? Tau prime is sigma xx minus sigma yy by 2 sine 2 phi, that is 180 degree plus 2 phi, and that becomes tau prime becomes 180 degree plus 2 phi is minus sine 2 phi, so minus sigma xx minus sigma yy by 2 sine 2 phi, that is tau is minus tau prime. So this is the relationship between complementary, this is for complementary normal stress and this is for complementary shear stress. By Mohr circle, how we can determine the complementary stresses, value of complementary stresses, that is, sorry, the relationship we got, sigma n plus sigma n prime is sigma xx plus sigma yy. This is one relationship, and tau is minus tau prime. Now the question is how to determine the complementary stresses from Mohr circle. So this is tau n, this is sigma n, and this is tau. Say this is point A, sigma xx comma 0. This is point B, that is sigma yy comma 0. And this is point C. This is the Mohr circle. Now say if this is point D, that is this angle is 2 phi, then coordinate of complementary stresses, that will be 180 degree apart from D, that is this point. So coordinate of D prime will give the complementary stresses, that is this angle is 180 degree. So calculate the coordinate of D prime. Say this is E prime, so is OE prime, and tau prime is E prime D prime. Now calculate it, you will get the same expression what we have determined earlier by analytical method.